All right, it's time for our next one in the review sheet. It's G in the review for exam 3. It's taking us a while. Um, Here we go, and that's what I meant to do. So we're up to 17. We're getting there. 17 is also on the little bit on the long side, but after that, the last three I think are shorter, are quite shorter. All right, anyway. So here's what you presented. There's also an A and B. So here's A. It gives us xy squared plus 8 equals 0. Plus 8 equals 0. And on Alex, it's asking you about the symmetry. And let me show you what that means, the symmetry. It'll have a little box. Is it symmetrical around about the x-axis? And you'll either check, if it's yes, you check it. If not, you just don't touch it. How about if it's symmetrical around the y-axis? If yes, you check yes, and if no, leave it alone. And how about around the origin? If yes, you check it, and if not, you leave it alone. Okay, so and it could be none. There's another possibility that it could be none. It's not symmetrical around any of them. All right, that's how it appears on Alex. All right, how do you check for symmetry? It's going to be quite simple. You got to remember it, but it's going to be quite simple. To check to see if it's symmetrical around the x-axis, right? The first question's first. So what you do is you put in, instead of y, put a negative y in there. So copy it. I'm sorry. This is supposed to say x squared. I apologize. And this is supposed to be plain y. X squared y plus 8 equals 0. That's the question. Sorry about that. So x squared you leave alone. Y you change to negative y. And that's all. That's the only change you make to check for symmetry around the x-axis. Plus 8 equals 0. Now, is this going to turn out to be the same as that? Look what the negative is going to do. We'll put it in front of the negative x squared. It'll turn negative. This is positive. So they're not the same. Not the same. So therefore, forget it. It's not symmetrical around the x-axis. Leave this box alone, right? So it is what we conclude here on scrap paper. It is not symmetrical, right? About x-axis, and therefore you leave that box alone. Okay, next piece of work. What if we're testing to see if it's symmetrical about the y-axis? All right, so for that, you take the original, don't forget the original, and instead of x, you put in a negative x. A negative x. Leave everything else alone. Leave the y alone, the plus alone, the 8 alone, the equals alone, the 0 alone. Just replace x. Let's leave the square alone. Just replace x with negative x. What's going to happen to negative x to squared? It's going to turn into x squared. So is this going to be equal to the original? The answer is yes. So therefore you check, yes, it is symmetrical about the y-axis. Because when you put in negative x where x is, it turns out to be the exact same as the original. So the answer is it is going to be symmetrical about the x-axis. All right, so our next test, our last test, what about the origin? To test to see if it's or if it's symmetrical about the origin, so then put in, instead of x, put in negative x, and instead of y, put in negative y, plus 8 equals 0. Now, let me do a little extra scrap work. This will turn into x squared, but that minus is going to be a minus when y, I could put the minus here, but it's not, it's awkward. Put it in front. Plus 8 equals 0. Now, is this the same? Is this the same as the original? No. So it is not. In conclusion, leave that box alone. Don't put none either. One of them was good. So now, what do we conclude? We conclude that it's not symmetrical. It's not symmetrical about the origin. About the origin. That is how you deal with this problem. So to test for the symmetrical about the x-axis, replace y with negative y and see if it's the same. To test to see if it's symmetrical about the y-axis, replace x with negative x and see if it's the same. To see if it's symmetrical about the origin, replace both x and y with negative x and negative y and see if the result is the same. That's the test. Okay, that was 17A. Let's go to 17B with a new piece of paper. It eats up a lot of paper, but it's not necessarily hard. Okay, let me show you 17B. 17B looks like this. The problem is, let me put right that, 17B. And what does it say on your test? What's the given? X squared plus 23y squared is equal to 53. Now you might notice right away that this is a circle. And a circle turns out to be symmetrical about the x-axis, y-axis, and the origin. But I'm going to prove all of this to you. So again, it's all about the symmetry, right? And Alex will have this. Alex will have the symmetry thing. It'll have the boxes. They'll ask you about, what about the x-axis? Symmetrical about the x-axis. Symmetrical about the y-axis. Symmetrical about the origin, or the possibility that it's none. Now, what do? The exact same thing we did before. For the first test, make y into negative y. We're testing for symmetrical about the x-axis, so make y into negative y. So write x squared is scrap paper. X squared plus 23. Instead of y, write negative y. Everything else leave the same. Squared equals 53. Is that going to turn out to be the same as the original? Yes, because negative y times negative y is y squared. I'll get back to the original. So, yeah, it is symmetrical about the x-axis. Okay, there's the first test. Second test, change x into negative x. X turns into negative x squared. Leave everything else alone. This is 23. 23. Equals 53. What'll happen? What'll negative x times negative x turn into? X squared. So does this turn out to be the same as the original? Yes. So it tests positive for being symmetrical about the y-axis. Checking this. Okay, but about the origin. That means you have to put in both. Change x into negative x. Leave the squared alone. Plus 23, change y into negative y, leave the 23, leave the squared alone, equals 53. Will this turn into regular x squared? Will this turn into regular y squared? Yes, that means it's equal to the original. That means it's symmetrical about the origin. And of course it's not none. And then problem 17 is over. That's how you test for symmetry. All you got to do is remember those tests, and I don't think you'll find it to be so terribly hard. Here comes 18. We're getting to the finish line. What if it says, a pretty simple problem, P is equal to A plus 2 plus C, and it says solve for C. So that means we got to get C isolated either on the left or the right. To get C isolated, do a minus A and a minus 2. If you do that to the left, you got to do that to the right. So I have P minus A minus 2. These are gone, equals C. And it's isolated for C. So go look on your, right into on your answer sheet, or into Alex. C is equal to P minus A minus 2. And they could rearrange it any way they want, but I assume they would have it in this arrangement. And that's it. That wasn't meant to be a difficult problem. All right, how about number 19? Let's move the paper up. Move the paper up. 19. Okay, what if you've got A, 1.43 times 10 to the 5. You can see that we're talking about scientific notation. Let's say it's talking about kilometers. Okay, and it's supposed to be changed into standard notation. Standard notation, which means a regular number that we're used to. That's a fancy name for regular numbers. Okay, they want it to be regular number, right? So you take 1.43. You take let me put it over here. 1.43. Move over the decimal place. How many places? 5 to the right. Right? It's big. These aren't minus. It's positive, so it's big. So it's going to the right. 1, 2, 3 a gap, 4 a gap, 5 a gap. So now this turns into, the answer is 1, 4, 3, 1, 0, 2, 0, and 3 zeros, and that's it. It's 143,000 kilometers. Okay, that's 19A. Now what about B? Here comes B. What if you have point, and then how many zeros? 3 zeros. 1, 2, 3. Then 5, 3, 2. Let's say they say meters, whatever. They seem to be enamored with the European system. And they wanted you to change it into scientific notation. Scientific notation. Okay, so the answer is you take the significant numbers, which are 5, 3, 2. Put a decimal right after the first digit on the left. We talked about that. And it's got to be multiplied times 10. You can see this is small, so we need a negative exponent over here. What's our negative exponent going to be? Well, here's where, let's use this as scrap paper. How many places do I have to go to get back to the decimal place? 1, 2, 3, 4. So you put a negative 4 over here, and that's it. This is the answer to this problem, and this is the answer to this problem. Last problem, number 20. Get a new sheet of paper. Get a new sheet of paper. Come down here, sheet of paper, and let's do number 20. Okay, number 20. What is it? Rationalize the denominator. We've had this before. Rationalize denominator. Okay, what's the given? The given is minus 9 over the 3 square root of 3 plus 2. What did we learn? We learned multiply both the top and the bottom of the denominator. Get the conjugate of the bottom, which is 3 square root of 3 minus 2. Multiply the bottom by that, but also multiply the top by that. Where does that get us? On top. On top, negative 9 times 3 is negative 27, square root of 3. Right? Negative 9 times this, and then negative 9 times negative 2 is positive 18. Okay, let's leave that alone for the moment. When you multiply by the conjugate, what happens? First times first, the middle ones are going to cancel out. So just the first times first and the last times the last. First times first is going to turn into 3 square root of 3. I'll do a little scrap paper over here. 3 square root of 3 times 3 square root of 3. What's the square root of 3 times square root of 3 is going to turn into 3, right? Okay, square root of x times square root of x is x. 3 times 3 is going to be 9. How much is 9 times 3? 27. How about last times last? Positive 2 times negative 2 is negative 4. Okay, what do we have? Our Alex is going to have, he's going to probably like it like this. Negative 27 square root of 3 plus 18 over 20. What's 27 minus 4? 23. That's it. And you can't even reduce any further. Or it would have 18 on the other side. Or possibly 18 minus 2 square root of 3 over 23. And we've separated class, give 23 to the 18 and 23 to the minus 2 square root of 3. But I don't think Alex does that. Alex will leave it like this. Okay, so there is our final answer for problem number 20. We have finished the review finally.